There's a place somewhere on Earth right now that is as dim as it is at noontime on Pluto. NASA calls that Pluto time and has made an app to help you figure out when it's Pluto time where you live. If you define the distance from the Sun to the Earth as 1 astronomical unit, then at 2 AU away from the Sun, just past Mars, it's 4 times dimmer thanks to the inverse square law. An f-stop is a change of light by a factor of 2, so every time we double the distance, we lose 2 f-stops of light. At 4 AU, close to Jupiter, we lose another 2 f-stops of light, making it 16 times darker. At 8 AU, close to Saturn, the light is 64 times dimmer. At 16 AU, heading toward Uranus, it's 8 f-stops, or 256 times dimmer. Finally, at 32 AU, it's a full 10 f-stops, or 1024 times dimmer. If you've ever seen a 10-stop neutral density filter, you know it's pretty dark, so you might imagine it's hard to photograph Pluto, but we get images that are fairly well lit. How is that possible? According to the Sunny 16 rule, you can get a good exposure on a bright sunny day on Earth by setting your camera to f16 and making your ISO and shutter speed reciprocal, let's say 100 and 1/100th. If you're on Pluto, which is 10 f-stops darker, you might brighten your exposure 5 stops just by opening your aperture to f2.8, and you could get the other 5 stops by changing your ISO to 3200. Those are reasonable camera settings for doing a photo shoot on Pluto. If you're on Mercury, it's 2 f-stops brighter there.